Welcome to another installment of My Two Cents. Today's topic is going to be the age of the Earth. So how do we know how old the Earth is? First, let's figure out how old is the Earth. The Earth, scientifically speaking, is 4.5 billion years old. The universe, scientifically speaking, is 14.9, give or take, 14.75 billion years old, give or take 0.17 billion years, something like that. Anyway, the Earth is 4.5 billion years old. We know this based on nuclear chemistry. Nuclear physics, which I prefer to call nuclear chemistry. Nuclear chemistry is the study of the atomic structure of the atomic particles. If you don't know what an atom is, or if you aren't familiar with quantum physics, basically, when you start from our scale, which is yourself and everything that you observe, you can go down to the smallest components in the smallest components of matter, which are the atomic particles. As you start going down, you get to the atoms. That means that if you take any object, matter, any type of matter, be it a solid, a liquid, or a gas, and you divide it, and you continue to divide until you can divide no more, you'll reach the atoms. The atoms are the smallest unit of matter in the universe. The atoms themselves can be comprised of what is known as quarks, but I'm not going to really go into that. I want to stay on just where I am right now. So we have atoms comprised of protons, neutrons, and electrons. The simplest atomic particle in the universe is the hydrogen atom. The hydrogen atom is comprised of one proton and one electron. From the hydrogen atom, we get all the other elements through stellar fusion, which is the formation of elements in a star, which is also the driving force of the stars themselves. The stars being the celestial body or the sun that Earth and planets orbit around. From this, and this is all relevant to the age of the Earth too, by the way. From this, we get the chemical compounds. So you start with hydrogen, and in the formation of a star, 2 hydrogen molecules combine to form a helium molecule. 3 hydrogen molecules form a lithium molecule. Elements. And this goes all the way up till you get to the highest known elements, which are uranium, etc., plutonium, iron, lead. All of the chemical elements are formed this way. So what is the relevance? The chemical elements form chemical compounds. The chemical compounds form chemical substances. And the relevance to this is that when you look at the age of the universe, the age of the Earth, also the age of the universe, but specifically the age of the Earth right now, what you find is that the actual atomic particles comprise the chemical elements that comprise the information we use to determine and date the age of the Earth. The way we do this is with a thing called radioactive decay. Radioactive decay occurs in elements, and what's the word I'm looking for? Basically, I already suggested that one hydrogen molecule is comprised of just a proton and an electron. A collection of hydrogen molecules form a chemical substance. If you take a chemical substance like hydrogen and oxygen, you combine them together, you can create a chemical compound like water. So hydrogen bonds with the hydrogen and oxygen combine together to form water molecules. The combination of a collection of water molecules form water. The same thing occurs in the physical matter, such as metals and dirt, as far as the semiconductors, the metals, the metalloids, the noble gases, etc., are all chemical compounds found on Earth. We use the rocks and the metals, the non-gases, to determine the age of the Earth. We use carbon dating to take uranium particles, uranium matter, and uranium compounds, and we check the half-life of their radioactive decay to determine the actual age of the substance. We can look at a particular piece of matter, and we can check and count the numbers of uranium molecules, and we know this is supposed to be a pure substance of uranium. Basically, this block of matter should be nothing but uranium. We can look inside of it, and we can see that that's not the case. That some of the uranium is actually, in fact, lead. The reason for this is radioactive decay. Radioactive decay allowed some of the uranium molecules to reverse transmute into lead molecules. or the lead chemical element itself. And it is this process that allows us to determine the age of the universe. We can count the number of particles of the uranium versus the lead to determine the age of the material based on the half-life equations, which are numbers to determine exactly how long it takes a substance to decay to another material. What I'm basically saying is this: in a star, under the process of nuclear fusion, one hydrogen molecule, one proton, and one electron combines. The actual particles are forced together to create a helium molecule. The helium molecules are forced together to create, I'm not going to be able to say off the top of my head, the borium. They're forced together to form borium, the fourth atomic part, the fourth chemical element in the periodic table. Two borium molecules, two chemical elements of atomic number 4 combine to form atomic number 8. Two chemical elements of atomic number 8 combine to form atomic number 16. Two chemical elements of atomic number 16 combine to form atomic number 32. This goes on all the way to hydrogen, and then it stops. During a supernova explosion, which is the death of a type 1 star, the gases that are thrown out come back together and coalesce to form a type 2 solar system. Our sun is a type 2 star. Type 2 star forms, and around it, in the accretion disk, forms the planets of the heavier elements. This is the basic premise of this is that in the early universe there was only hydrogen and helium. The death of hydrogen and helium gave formation and gave rise to the higher elements above iron. Since our Earth has elements higher than iron in it, then the Earth must have formed from solar systems or accretion disk of nebulas left after the death of type 1 stars. The type 2 stars gave rise to our planet and our sun. Our sun has heavier elements in it, and that is because it is formed from the death of type 1 stars. When our sun dies, it will give birth to type 3 stars, which will have heavier elements than are found in type 2 stars at the birth of them, because the stars themselves are forming heavier elements. So when the type 1 star died, the elements from the type 1 star, the chemical elements, the hydrogen, the helium, the lithium, the borium, the carbon, the oxygen, the neon, the kryptons, the iron, the gold, the aluminums, all of those chemical elements combined to form the stratus that is the Earth. When two or more different elements combine, you get a chemical compound. For instance, hydrogen and oxygen are chemical elements. When hydrogen bonds with oxygen, you get a chemical compound, water. Sodium and chloride are chemical elements. When they combine, you get the chemical compound, salt. When two chemical compounds combine, salt and water, you get molecules of salt water. You get the actual combination. This is what took place in the Earth. This is what science is using to determine the age of the Earth, because the Earth itself is comprised of, based on geography, indigenous, metamorphic, and sedimentary rock. Indigenous rock is lava rock. Sedimentary rock is rock that's formed from sediment. So when rock is all broken up and falls apart, you get sediment. Metamorphic rock is rock that has been reshaped over time. The first rock starts with indigenous rock. The indigenous rock is the lava rock. So on the early Earth, when the Earth was a big ball of lava, and it was basically devoid of X amount of impurities like water, salt, and all the other chemical substances, it formed the foundation of the strata on Earth. From that, other chemical elements got mixed in with that, and from those other chemical elements, the Earth began to form other compounds with the indigenous rock. This is how sedimentary rocks formed. The sedimentary rock formed from the sedimentary rock itself was reshaped by heat, pressure, wind erosion, etc., and formed metamorphic rock. Also, indigenous rock can be formed straight into metamorphic rock as well. But science can look at the particular rocks themselves and look at the chemical elements in them and determine when, where, why, and how they formed. They can also check the dates of the half-lives of these chemical compounds and determine more information on them as well. For instance, you could have a strata